As promised, I will demonstrate how this project works on these video demonstrations. Before that, let me explain this automated system flowchart. It will start by the display automated system interface, which is GUI, graphic user interface. After that, user will choose the type of CNN model, which in this study is GoogleNet. And then user will browse the chest X-ray images that they need to classify, followed by classify button to be clicked, and finally the system will display the results. If the system does not display the result, it will appear a text box with contain message that this cannot be classified as the user does not select the CNN model at the first place. Therefore, the user needs to select the CNN model back and repeat the process until the system able to display the result of classification, either COVID-19 happened because of pneumonia or other disease pneumonia. Firstly, we open the automated system that had been developed to classify COVID-19 and other pneumonia from chest X-ray images. After that, the automated system will display graphic user interface as shown here. On the left side of the automated system, having 3 buttons for user to use, and on the right side is displaying the results. First, we select the CNN model that have been trained previously. As recap, this project shows model GoogleNet having highest accuracy of classification chest X-ray images. Therefore, GoogleNet will be selected and used in this automated system. Then, open image randomly. As for now, we pick one of the chest X-ray images in COVID-19. For example, this patient, and the selected image load have been displayed, and once classified button being clicked, the image will feed to the My Train CNN, which is GoogleNet, and result will appear at the right side. As shown here, the result have been predicted the image as COVID-19, same as the class of the image. This shows the accuracy of the probability of this image belong. As we can see, COVID-19 show the highest probability score, which is 99.9%. So, this reflect as the result having this image as COVID-19. Now, let's see if we choose another images from bacterial pneumonia. Either the system can detect or not. For example, for this image, we open it and then classify. As shown here, it gives result as bacterial pneumonia. Moving on to the testing in viral pneumonia. For example, we choose image randomly for these images 2186 and classify it as viral pneumonia as shown here. it gives the probability accuracy in classify the image 76.7. And lastly, we testing on normal images. For example, we took image and classify it as normal images. As shown here, this image is obtained from a female patient. So we can see the variety of image dataset is using male and female. Let's see if we skip this button on select the CNN model. For example, we just jump to the cross image. For example, we take this image, it still can load the images into the system. But when we click the classify, it will display message text box that say cannot classify the image, and user need to select the CNN model first. Therefore, this automated system model gives very quite promising results in predicting the image perfectly. This model is the fastest screening artificial intelligence system which allows healthcare officers to distinguish types of pneumonia on patients either caused by bacteria, viral, or even COVID-19 itself. If the patient having pneumonia because of COVID-19 and the system can detect it, so early precaution can be made to prevent the outbreak of COVID-19, and patient will be isolated to the special room for doctor to give desired treatment. I hope that this automated system model will give a helping hand to our nation to fight against the COVID-19 war and to avoid the fastly spreading of this virus. Sadly, this is end of my presentation. I would like to thank Dr. Maria and Dr. Rani for lending your ears for listening my presentation. I wish Doctor have a good day and Assalamualaikum. Bye.